Okay, guys, so we are going to look at some notes from Chapter 2. We will cover Chapter 2 a little bit differently. We will not be going section by section. A few years back, we had to look and prioritize what material we needed to cover when they changed the frameworks, and we found out that some of the stuff in Chapter 2 is not essential. So especially this year when we're really pressed for time because of the shorter amount of days, we are just going to go through the key vocabulary from Chapter 2, and you will see it. It is going to be important, okay? But we're not going to go section by section. So the first definition we're going to look at are two lines are called perpendicular lines, okay? If they intersect to form a right angle. So if you have lines that do this, okay, and they tell you that one of these is a right angle, and a lot of times they'll put a little box there, that means that these lines are perpendicular. If this was A and this was B and this was S and this was T, the way we would write that is we would say line ST is perpendicular to going AB. Okay? And it makes a 90-degree angle there. And we're going to learn quickly that once you have one 90-degree angle here, they're all going to be 90. Okay? We're going to learn that in this chapter. Okay? In this chapter. So, perpendicular lines, important definition. Okay? We will use that over and over and over and over again. So now we're moving on to section 2.4, okay? And we're going to talk about all kinds of properties, okay? And some of these properties are going to be important when we get into proofs. So it is something that you do want to pay attention to, okay? And the first one's called the addition property. So what I will do is I will give you the property with letters, and then I'll give you an example of how you see it. Where do you see this kind of property? In geometry, it's not good enough to know the answer. You have to have a reason why. Okay, you have to have a reason why that's the answer. Okay, that's just what geometry is all about. So the addition property says if A equals B, then A plus C equals B plus C. So in essence, what this is saying is if you start with two things that are the same, and you add the same thing to both sides, what you get is still the same. So where you would see this and where you would list it as a reason is if you had an algebra problem that said x minus 4 equals 10. And you said, okay, well, I'm going to add 4 and get x equals 14. If you had to give a reason for that, that's the addition property. You started with two things that were equal to each other. You added the same thing to both sides. What you got were two things that were equal to each other. So if you saw that and that made sense, you can imagine what's coming next. That's going to be the subtraction property. Okay? And your subtraction property starts off the same way. Okay? If A equals B, then A minus C equals B minus C. So if you start off with two things that are equal, you subtract the same thing from both sides, what you get is still equal. So if I had x plus 4 equals 11, and I said minus 4, x equals 7, if they asked you for a reason for that, that's the subtraction property. Why? I started off with two things that were equal. I subtracted the same thing from both sides. What I got was something that was equal. Okay? So if we have addition, we have subtraction. You know what's coming next. Multiplication. Okay? It's important to have these into your notes because we are going to use them. You'll see why shortly. Okay, so now if we say if A equals B, then A times C equals B times C. You start off with two things that are equal. You multiply both sides times the same thing. What you get is still equal. So if I had x over 2 is equal to 5, and I wanted to solve for x, and I said I multiply by 2 and I multiply by 2 and x equals 10, that's an example of the multiplication property. Okay? Next one. We're going to have the good old division property. Okay, the division property. So if A equals B, then A divided by C equals B divided by C. You start off with two things that are equal. You divide both sides by the same thing. What you get is still equal. This will hold as long as C isn't 0, because you can't divide by 0 in mathematics. So if I had 5x equals 15, and I divided by 5 and divided by 5, and I got x equals 3, that's an example of the division property. Okay, the division property. So we've got a few more. This first one, you're going to look at it and you're going to say, well, I don't understand the point. And we will in chapter 4. It'll make sense in chapter 4, and that's our reflexive property. And what the reflexive property pretty much says, for any real number, A equals A, 5 equals 5, 7 equals 7, AB equals AB. These are all the reflexive property. You have something, it's equal to itself. If they give you this and they ask, well, 5 equals 7, that's not right. 5 equals 5. 5 equals 5, AB equals AB. If you see that, if you see it and they say, what's the reason for that? You have to say the reflexive property. Okay? This next one's not seen very often, but I'll give it to you. And it's called the symmetric property. Okay? And that says if A equals B, then B equals A. Or if 5 equals 4 plus 1, then 4 plus 1 equals 5. It's like just switching what's on the sides of the equal sign. Again, not that important. Okay, this one you'll see this in proofs. Okay, this one here, not as much. And then we have what's called the transitive property. This one you'll see, I'm going to put 2 stars next to that one. Transitive property. So the transitive property says if two things equal the same thing, then they're equal to each other. So if A equals B and B equals C, then A equals C. If two things are equal to the same thing, then these things are equal to each other. And that one, I can tell you right now, we will see. Okay? The distributive property, you're familiar with this from algebra. Okay? The distributive property tells you that if you have, if A times B plus C, if you have this, then that's equal to AB plus AC. So if they give it to you in a math problem, they say something like 3 times x minus 2, and then the next step says 3x minus 6, and they say, what's the reason for that? That's the distributive property. We can distribute like that. Okay? There's one that says, it isn't as well known, it's the substitution property. Not as well known, not as used as much, but it says something like, if A equals B, then A can be substituted for B in any equation or expression. Again, not going to see that much. It's kind of a rare little property. So again, you're going to see examples like this, and they're going to say, what property is that? Okay, or how can I say that? So here comes our first proof. Okay, we're going to deal with 2-column proofs a lot, and on the left you're going to have what are called statements, and on the right you're going to have what's called reasons. Okay, so the first one's going to say something like 2x plus 6 equals 40. Okay, and I don't know if I want to use 40. I'm going to try to, I might pick 48 so it comes out nice and even for us. Well, we want to solve this equation on this side, and then we want to give a reason for our steps on that side. So you have to start somewhere, and whatever that they give you is called the given. Okay, that is just given to us. So step number 2, to solve this, I'd say 2x plus 12 equals 48, right? Now what's the reason for that? What did I do there? I distributed. So the reason is what allows us to do that? The distributive property. Okay? I'll write bigger. I can see myself writing small. So now my next step would be to go minus 12 minus 12 minus 12 minus 12, and I get 2x equals 36. What did I do to both sides? That's subtraction and the subtraction property. And then my last step is to divide by 2 and divide by 2. So x equals 18. What did I do to both sides to solve? I divided. That's my division property. Okay? That's our first proof. Okay? You did your first proof. A lot of geometry is about proofs. So good for you. You survived the first one. Okay? So I'm going to give you guys one I want you to try. I don't know. I'll put distributive property in there again. So you got to start off with a given. So what I want you guys to do is I want you to pause the video, and then I want you to try that. Okay? Pause the video and try and see what you got. So I am sincerely hoping that you pause that video so that you're getting something out of this. Okay, I really do. Because if you're not, then man, what are we doing here? What's the point? You know, I want you to do well in geometry. I want you to go on and say, yeah, that guy taught me something. All right, I don't want you to go on and say, yeah, I didn't learn anything in there. So, number 2, we distribute, and that's going to be 3x minus 15 equals 30. What did I do? I used the distributive property. Okay. Step 3, I'm going to add 15 to both sides. That's what I would do in algebra. So I'm going to get 3x equals 45. What did I do to both sides? Addition. So that's the addition property. And then my final step, step 4, divide by 3, and x equals 15. And what did I do? I used the division property. Okay, so the only other thing that you'll look at with these is you could have something like this, all right? If, I don't know, the measure of angle, I don't know, J equals 10, then 3 times the measure of angle J equals 30. And so what you would do is you would ask yourself, how do you get from the if to the then? What am I doing? What am I doing to both sides? Here I have measure of angle J, here I have 3 times the measure of angle J. Here I have 10, and here I have 3 times 10. So what is that? I'm multiplying both sides. That's the multiplication property. Okay, so that will be the first video. That will cover our first video in chapter 2. Okay, we will have one other short video that will cover the vocabulary in the last 2 sections, but I think that's probably enough for right now. You'd be able to do some of the problems that I'm going to assign, okay, and then I'll wrap it up with the last one.